The Great Sphinx of Giza is hiding a secret in its stone. This video reveals the geological evidence that this iconic monument could be far older than ancient Egypt itself. You will gain a new understanding of human history, one where the timeline you know might be rewritten by the very ground beneath our feet. Why does the stone show signs of a climate Egypt has not seen for thousands of years? What forgotten chapter of our past does this silent guardian represent? How does it feel to stand before a mystery that defies our textbooks? For over a century, the official story has been clear and compelling. The Great Sphinx, we are told, was carved from the bedrock of the Giza Plateau around 2,500 years before the Common Era, during the reign of the pharaoh Khafre. It is a cornerstone of ancient Egyptian history, its face often said to be a portrait of the king himself, forever gazing eastward from the shadow of his pyramid. This dating isn't a guess, it's built on a foundation of archaeological context, the alignment of the Sphinx with Khafre's Valley Temple, and the absence of any older inscriptions claiming its creation. In the world of Egyptology, this timeline is the bedrock upon which so many other stories are built. It fits neatly into our understanding of the Old Kingdom, a period of powerful god-kings and monumental ambition. But science and history have a way of surprising us. The most stable stories, the ones we take for granted, are sometimes the ones most vulnerable to a single, inconvenient piece of evidence. What happens when the stone itself starts to tell a different story? Look closely at the sides of the Sphinx enclosure, those deep trenches from which the great statue was carved. The stone there tells a story of violence, but not from sand and wind. You see vertical fissures, deep channels, and undulating, scalloped hollows that look less like a desert sculpture and more like something carved by a relentless, pounding force. These are the classic signatures of water erosion. Specifically, they are the scars left by torrential rain falling over centuries, water cascading down the walls, dissolving the softer limestone layers and leaving behind those distinctive vertical runnels. Wind and sand erosion, the forces that dominate the Egyptian landscape today, create a very different pattern. They sandblast surfaces smooth, creating horizontal weathering and rounded, flowing shapes. The Sphinx enclosure shows both types, but the deep vertical weathering is undeniable and, to many geologists, unmistakable. This observation, seemingly so simple, became the first major crack in the conventional timeline. It was brought to global attention in the early 1990s by a Boston University geologist, Dr. Robert Schoch. Trained to read the language of rock, Schoch did not approach the Sphinx as an archaeologist looking for pottery shards or inscriptions. He approached it as a geologist examining a rock face. His conclusion was startling. The profound weathering on the Sphinx and its enclosure walls, he argued, could not be the work of a mere 4,500 years in an arid climate. This was the work of many thousands of years of exposure to a very different Egypt. He pointed to a period known as the Neolithic subpluvial, a time when the Sahara was not a desert but a green savanna, dotted with lakes and crisscrossed by rivers. This wet phase, researchers believe, ended around 5,000 years before the Common Era. For the Sphinx to show such clear evidence of water erosion, Schoch proposed its origins must stretch back to that wet period, potentially placing its initial carving centuries, even millennia, before the first pyramids were conceived. Suddenly, the Sphinx was no longer just an old kingdom monument. It became a possible relic from a forgotten epoch, a monument built by a culture lost to time, gazing out from an age when the land around it was alive with water and life. But geology isn't just about what we can see on the surface. It's also about what lies beneath. To truly test the water erosion hypothesis, researchers needed to look deeper, literally. They turned to the tools of modern geophysics, using sound waves and radar to create a picture of the hidden world below the Sphinx enclosure. One such study, conducted by geophysicist Thomas Dobecki, used a technique called seismic refraction. By sending sound waves into the ground and measuring how they bounced back, his team could map the density and structure of the rock layers beneath the monument's floor. What they found was startling. The data revealed a clear pattern of subsurface weathering that extended several meters down into the bedrock. This wasn't surface damage from wind-blown sand. This was deep, pervasive alteration of the stone, consistent with long-term saturation from water seeping down from above. Think of it like a sponge. If you pour water on a dry sponge once, it dampens the surface. But if you leave that sponge out in frequent rain for years, the water soaks all the way through, changing its very core. The seismic data suggested the bedrock beneath the Sphinx enclosure had been that sponge, subjected to a prolonged, soaking environment. Furthermore, the analysis pointed to something called differential erosion. The weathering patterns in the enclosure floor appeared more advanced, more deeply etched than the weathering observed on the body of the Sphinx statue itself. This creates a puzzling timeline. If the Sphinx and its enclosure were carved at the same time, as the conventional story states, they should show a similar degree of weathering. The fact that the floor seems older suggests a sequence of events. One compelling interpretation is that the core body of the Sphinx was recarved from a much older, pre-existing monument that had already been sitting in that weathered enclosure for centuries, its original form softened and reshaped by millennia of rain. This subsurface story adds a powerful, three-dimensional layer to the argument. It's no longer just about the walls you can see. It's about a history written in the stone you cannot see, a chronicle of water and time that seems to stretch far beyond the dry desert age of the pharaohs. If the very floor it sits on tells an older tale, what does that mean for the guardian above it? The most powerful evidence often comes not from a single anomaly, but from a stark contrast seen side by side. To truly understand the Sphinx's story, we must step back and see it within its family, the other monuments of the Giza plateau. Just a short walk from the Sphinx lies the Valley Temple of Copper, a massive structure built from enormous limestone blocks. According to the traditional timeline, this temple and the Sphinx were constructed by the same pharaoh from the same local bedrock and have stood under the same sun and sand for the same 4,500 years. They are siblings in stone, yet when you look at their surfaces, they tell two completely different stories of aging. The limestone blocks of the Valley Temple show the expected wear of a desert environment. Their surfaces are smoothed and rounded by the abrasive kiss of wind-blown sand over millennia. You see horizontal weathering, the gentle scouring of countless desert storms. It is exactly what you would predict. Now turn and look back at the body of the Sphinx, at its deeply fissured flanks and the undulating walls of its enclosure. The weathering pattern is not horizontal and smooth. It is vertical, deep, and chaotic, the signature of water cascading down its sides. This creates a profound geological puzzle. If two structures made of the same stone, located in the same place, were exposed to the same elements for the same amount of time, they should look roughly the same. But they do not. The disparity is not subtle. It is a shout from the stone itself. This forces a simple yet revolutionary question. What if they were not exposed to the same elements for the same amount of time? The most logical explanation for such a dramatic difference is that the Sphinx experienced a climatic chapter that the Valley Temple did not. The Sphinx, according to this geological reading, endured centuries of heavy rainfall, a wet phase that ended long before the blocks of the Valley Temple were ever quarried and set in place. The temple only knows the dry, sandy Egypt of the pharaohs. The Sphinx remembers a greener, wetter world. It stands as a solitary sentinel from that forgotten age, its body a time capsule of erosion that its younger neighbors simply cannot share. This comparative analysis turns the entire plateau into a geological clock. The differing weathering patterns are like two trees with different numbers of rings. One tells a shorter, drier story. The other holds within its form the memory of ancient storms. Of course, such a radical claim did not go unanswered. The halls of academia erupted with a fierce and necessary debate, a classic clash between established history and a disruptive scientific observation. Mainstream Egyptologists and geologists presented powerful counter-arguments, aiming to explain the Sphinx's unique weathering without rewriting the timeline. Their primary weapon was a process called haloclasty. This is where salts, drawn from groundwater or even from the stone itself, crystallize just beneath the surface. As these crystals grow, they exert immense pressure, spalling off flakes and chunks of rock. Proponents of this view argued that the porous limestone of the Giza plateau has been subjected to cycles of morning dew and capillary action, where moisture from the sand below wicks up into the stone carrying dissolved salts. Over centuries, this internal pressure could create fissures and recesses that might, from a distance, resemble water erosion. They pointed to the undeniable presence of salt crusts on parts of the monument as evidence. Furthermore, they suggested that occasional heavy Nile floods in antiquity, or even rising groundwater, could have periodically filled the Sphinx enclosure, causing localized saturation and weathering without requiring a prehistoric rainy epoch. This debate is not merely an argument over dates. It is a fundamental lesson in how we interpret evidence. Geology provides the data, the story written in the stone. But history and archaeology provide the context, the narrative into which that data must fit. One side sees the unmistakable signature of millennia of rainfall. The other sees a complex but more recent interplay of salt, humidity, and sporadic water. This places the Sphinx at a fascinating crossroads. It is no longer just a statue, but a battleground of ideas where the same set of scars can tell two completely different stories about our past. The truth, as it often does, may lie in the subtle details that neither side can fully claim. To settle this debate, we need to look at the Sphinx not as a single object, but as a layered historical document. Its body is a palimpsest, a stone manuscript written and rewritten over time. The most telling page in that manuscript is the contrast between its core body and the restoration blocks layered upon it. Stand before the monument and you will see two distinct types of stone. There is the original core limestone from which the great beast was first carved. This stone is deeply, profoundly weathered. It is fissured, pitted, and scarred with those unmistakable vertical channels. Then, surrounding this ancient core like a patchwork quilt, you see the restoration blocks. These are stones of various sizes and colors, added by pharaohs, Roman governors, and modern conservators over thousands of years to repair the crumbling guardian. The difference in their condition is staggering. The original body stone looks ancient, ravaged by time. Many of the restoration blocks, some of which are themselves centuries old, look remarkably fresh and crisp by comparison. This visual testimony is critical. It tells us that the most severe, deep weathering on the Sphinx did not occur slowly and evenly over its entire lifetime. It happened in one concentrated, devastating period long ago. The original core body endured an erosive force so powerful that it carved those deep runnels and hollows. Then, much later, people began the long process of trying to fix that damage. The first major restoration efforts that archaeologists can definitively date come from the Old Kingdom, the very era when the Sphinx is traditionally said to have been built. This creates a logical problem. Why would a statue freshly carved for Pharaoh Khafre already need extensive, major structural repairs within a few generations? It is like building a new house and immediately having to rebuild its foundation because the walls are crumbling. The geological evidence suggests a more coherent story. The core body's severe water erosion required a very long period of exposure to the elements, likely many centuries if not millennia. After this long, damaging chapter, a later culture, the dynastic Egyptians encountered a deeply weathered ancient monument. They saw a lion-shaped formation emerging from the sand, a sacred symbol from a forgotten time, and they claimed it, restored it, and perhaps recarved its features. The restoration layers are not just repairs, they are bookmarks in time, marking the moment when the Sphinx re-entered recorded history after a long, silent period of neglect. This gap in its custodial history is perhaps the most powerful clue. The stone suggests the Sphinx was old before the first pharaoh ever laid a stone upon it, a relic from a time outside of Egypt's memory, waiting patiently for a new civilization to find it and wonder at its origin. Geological evidence alone cannot rewrite history. For that, it needs a storyteller. The man who would bring the water erosion theory crashing into public consciousness was not a geologist, but an independent researcher and author named John Anthony West. A charismatic and unconventional thinker, West had long been fascinated by the idea of a lost, advanced civilization. When he encountered Schoch's geological analysis, he saw more than just data. He saw the key to a paradigm-shattering mystery, and he understood that to challenge a story as entrenched as Egypt's, you needed a stage. He found it in a documentary. In 1993, West and Schoch collaborated on a television special for NBC titled The Mystery of the Sphinx. The program presented the geological case with compelling visuals, contrasting the Sphinx's weathering with the smoother stones of the Valley Temple. But West's true contribution was framing. He presented the debate not merely as an academic disagreement over dates, but as a dramatic clash between rigid institutional dogma and bold empirical discovery. He positioned the Egyptological establishment as a priesthood guarding an outdated orthodoxy, resistant to any evidence that threatened its foundational narrative. This framing struck a powerful chord. It transformed the Sphinx from a static monument into a symbol of intellectual rebellion. The documentary was a sensation, winning awards and reaching millions of viewers who had never questioned the age of the pyramids. For the first time, a mainstream audience was presented with a scientifically backed argument that human history might be far older and more mysterious than their textbooks claimed. The public response was electric, but within academia, it ignited a firestorm of criticism. This reaction highlights a process some scholars call knowledge filtration. It's not a formal conspiracy, but a sociological reality. Established fields of study, like Egyptology, are built upon a consensus, a carefully constructed framework of dates, kings, and cultural evolution. New evidence is filtered through this framework. Ideas that neatly fit within the existing paradigm are easily accepted and published, but radical ideas that threaten to topple key pillars of that consensus face immense, often subconscious resistance. They challenge careers, textbooks, museum exhibits, and entire lifetimes of dedicated work. The water erosion theory was the ultimate radical idea. It wasn't proposing a slight adjustment. It was suggesting that the very timeline of a foundational civilization was wrong, implying the existence of a precursor culture with the skill and will to create such a monument. To accept it meant to admit that a central story of human achievement was incomplete. The backlash against West and Schoch was fierce. They were dismissed as fringe theorists, their methods questioned, their credentials scrutinized. This resistance is a crucial part of the Sphinx's modern story. The monument became a battleground not just over weathering patterns, but over who has the authority to interpret the past. Is it solely the domain of archaeologists and historians who work with artifacts and texts, or do geologists who read the language of the earth itself have an equal voice? This struggle makes the Sphinx more than a geological puzzle. It is a living case study in how human knowledge evolves. It shows us that rewriting history is a battle fought on two fronts. The first is in the field with chisels and seismic sensors, gathering evidence from the stone. The second, and often more difficult, is in the realm of human institutions and minds, challenging the comfortable stories we tell ourselves about who we are and where we come from. The silence of the Sphinx, therefore, echoes not just across the desert, but through the halls of academia, asking us a profound question about our own relationship with the past. Are we its humble students, ready to listen when the evidence speaks, or are we its stubborn guardians, determined to defend the story we already know? The rock itself holds a calendar, and its pages are the distinct layers of limestone that make up the Sphinx. To understand this, we must look beyond the statue's shape and into its very substance. The monument was carved from a specific geological unit known as the Member 3 stratum of the Mokattam Formation. This isn't a uniform block of stone. It's a layered cake of history composed of alternating bands of hard and soft limestone deposited over millions of years in an ancient sea. Some layers are dense and resistant. Others are softer, more porous, and far more vulnerable to the elements. When erosion occurs, these layers don't wear down evenly. The soft stone recedes quickly, while the hard stone protrudes, creating a stepped, undulating profile. This is the key. The pattern of erosion we see on the Sphinx enclosure walls isn't random. It's a direct reflection of this layered stratigraphy, etched away by a specific type of force. Wind and sand abrasion tend to smooth everything over, blurring the lines between hard and soft rock. But water is a precise sculptor. Flowing water seeks out weakness. It exploits the soft layers, gouging them out deeply, while leaving the harder layers as ridges. The dramatic, wave-like hollows on the Sphinx enclosure walls match this process exactly. They show the soft limestone layers deeply recessed, with the harder layers standing proud like ribs on a skeleton. This tells geologists something crucial. The erosion pattern is conformable with the strata. It follows the natural weaknesses of the rock in a way that only a prolonged, flowing water event could achieve. Think of it like a stack of different types of wood, pine, oak, and cedar, left out in the weather. If you sandblast them, they all get smoother together. But if you pour water over them for years, the soft pine will rot and gouge out deeply, the cedar may warp, and the hard oak will remain relatively intact. The result is a deeply textured, uneven surface where the material's inherent differences are dramatically exposed. That is what we see at Giza. This stratified erosion creates a kind of chronological record. By analyzing the depth of the recesses in the soft layers, geologists can estimate the duration and intensity of the water exposure. The math, based on known weathering rates for this type of limestone in a wet climate, points to a timescale that is difficult to squeeze into the arid Egypt of the last 5,000 years. The rock book suggests a chapter of rainfall that lasted for centuries, a chapter that concluded long before the first dynastic stone was set. So the Sphinx is not just a statue showing water damage. It is a geological archive. Its body is a sequence of events, a literal stone manuscript where each layer tells a part of the story. We are looking at a monument that recorded its own age in the very process of being worn down, and the story it tells is one of ancient storms, of a climate that vanished, and of a timeline written in rock that we are only now learning how to read. The wind that whispers across the Giza plateau today is not a gentle breeze. It is a sculptor's tool laden with fine, abrasive sand carried from the vast Sahara. For those who defend the traditional timeline, this wind is the primary artist behind the Sphinx's weathered face. They propose a detailed geomorphological process. The dominant north winds, they argue, have bombarded the monument for 4,500 years. Sand particles, acting like microscopic sandpaper, would preferentially erode the softer limestone layers, slowly carving out the recesses and leaving the harder strata to protrude. This process, known as aeolian abrasion, can indeed create undulating forms over immense periods. Proponents point to other rock formations in arid regions where wind has carved smooth, flowing shapes into cliff faces. They suggest that the Sphinx enclosure, acting as a natural wind tunnel, could have focused and intensified these sandy gusts, accelerating the weathering on its walls in a way that might mimic, to an untrained eye, the effects of water. This is a compelling argument from pure physics. It relies on forces we can observe and measure right now, today, outside the window of history. It asks us to see the Sphinx not as a relic of a forgotten climate, but as a masterpiece of patient desert wind. Then there is the silent, internal force of salt. This theory delves into the chemistry of the stone itself. The limestone of the Giza plateau is porous like a sponge. Over the centuries, groundwater levels have fluctuated. Capillary action can draw moisture laden with dissolved salts up into the body of the Sphinx. When the sun rises and temperatures soar, that moisture evaporates. The salts are left behind, crystallizing just beneath the stone's surface. But salt crystals do not sit quietly. As they form, they expand with tremendous pressure, prying individual grains of limestone apart from the inside. This process, called haloclasty, causes the stone to exfoliate, flaking off in sheets or rounds. It creates a pitted, crumbling texture. Experts who favor this explanation note the visible salt crusts on parts of the monument and the clear evidence of such flaking on its surface. They argue that occasional, catastrophic Nile floods in antiquity, or even periods of higher groundwater, could have saturated the Sphinx enclosure periodically. This would have driven salts deep into the rock, setting the stage for centuries of internal pressure and spalling. The rounded, hollowed features, they contend, could be the result of this cyclical soaking and drying, combined with the relentless wind, all within the known climatic history of dynastic Egypt. No ancient rainfall required. These alternative theories are not dismissals. They are sophisticated counter-narratives built on observable desert processes. Respected geologists and archaeologists present them to argue that the forces present in Egypt for the last 5,000 years are perfectly sufficient to create the weathering we see. They maintain that invoking a lost, wet epoch is an unnecessary complication, a violation of the scientific principle known as Occam's razor, which favors the simplest explanation that fits the evidence. This is the core of the scientific debate. It is not a shouting match between fact and fiction, but a quiet, persistent conversation between different interpretations of the same stone canvas. One side sees the unmistakable brushstrokes of long-vanished rainstorms. The other sees the patient, gritty hand of the desert wind and the hidden, crystalline force of salt. The enduring mystery of the Sphinx exists precisely because both explanations are geologically plausible. The great challenge, then, is isolation. Can we disentangle the effects of wind, salt, and water on a monument that has stood for millennia? Each force leaves a signature, but their marks have overlapped and blurred over time. The search for a single, definitive cause becomes a detective story where the clues have been rewritten by the very elements in question. This complexity does not weaken the investigation. It deepens it, reminding us that the Earth's history is rarely a simple story, and that the most profound truths are often found not in choosing one side, but in understanding the weight of the question itself. This leads us to the most profound question of all. If the stone story is true, and the Sphinx predates dynastic Egypt by thousands of years, who carved it? We are faced with a historical blank page, a gap in our collective memory that demands an explanation. The geological evidence, if accepted, doesn't just shift a date. It implies the existence of a culture, a society with the organization, skill, and vision to undertake a project of staggering scale long before the first pyramid was ever conceived. This is not about finding a forgotten pharaoh's name. It is about confronting the possibility of an entire chapter of human achievement that has been erased from the record. Who were they? This question naturally opens the door to speculative, yet deeply fascinating, realms of historical thought. Some researchers point to the concept of a Sphinx culture, a hypothetical, sophisticated society that thrived in North Africa during the wet Neolithic period. This would have been a time of abundant water and vegetation, a climate that could support larger, more settled populations capable of monumental labor. Without the written records of later Egypt, their identity remains a mystery, their story told only in the weathered stone they left behind. Others draw connections to the great flood myths found in cultures across the globe, or to Plato's account of Atlantis, a powerful civilization lost beneath the waves. It is crucial to frame these ideas not as wild fantasy, but as logical historical questions raised by stubborn physical evidence. When the geology points to a timeline that our textbooks do not cover, we are compelled to ask what might have filled that time. The idea of a precursor civilization is not an escape from science, but a challenge to our historical models. It asks us to consider human resilience and innovation in an era we have largely written off as primitive. Could a culture mastering agriculture and community in that green Sahara have developed the symbolic language and collective will to shape the bedrock into a guardian for the ages? The Sphinx, in this light, becomes less a statue and more a message in a bottle from a sunken epoch, a solitary artifact from a world that vanished when the rain stopped and the desert returned. Its silent gaze asks us to reconsider everything we assume about the linear progression of civilization. Perhaps human history is not a steady climb, but a story of cycles, of cultures that rise, create wonders, and fade, leaving only the most durable of their works behind as clues for those who come after. The implication of an older Sphinx is ultimately an invitation to humility. It suggests that the story of our past is far richer, more complex, and more mysterious than any single narrative can contain. We are left standing before a monument that may be a bridge to a forgotten world, a reminder that history is not just what was written down, but what was carved in stone by hands we have yet to truly name. Sometimes the most telling clues are not the grand monuments, but the small, forgotten things left behind. Deep within the sands that have filled the Sphinx enclosure over the centuries, researchers have uncovered something unexpected. Mixed with the typical limestone debris are fragments of a rock that does not belong. This rock is schist, a hard, metamorphic stone forged under immense heat and pressure deep within the earth. It is not native to the Giza plateau. The local bedrock is sedimentary limestone deposited by an ancient sea. Schist is an intruder in this geological story. So how did it get there? The presence of these foreign fragments opens a door to a fascinating, though inconclusive, line of inquiry. One compelling possibility is that these pieces are not natural debris at all, but the remnants of tools. Schist, due to its hardness and ability to hold a sharp edge, could have been an ideal material for stone hammers or chisels used in the monument's initial carving. If the Sphinx was worked on over a long period, or if it was recarved in a later era, broken tools could have been discarded and eventually buried in the accumulating sediments. Finding tool fragments is common at archaeological sites, acting like fingerprints left by the builders. But here, the material itself is the clue. It suggests the builders had access to or traded for resources beyond their immediate location. They selected a stone tough enough to shape the limestone guardian. This micro-evidence, while not definitive proof of an older date, complicates the simple narrative. It invites us to ask new questions about the technological capabilities of whoever first shaped the Sphinx. Were they using sophisticated stone working techniques that utilized different materials for different tasks? The schist fragment is a whisper, a tiny, physical echo of activity. It reminds us that grand constructions are built not just by vision, but by countless small actions: the strike of a hammer, the shaping of a block, the discarding of a broken tool. This forgotten piece of stone pulls our focus down from the majestic silhouette against the sky to the granular details at its feet. In the patient work of archaeology, it is often these anomalous details that hold the key to larger mysteries. A single fragment cannot rewrite history, but it can certainly question it. It prompts us to consider the toolkit of a hypothetical earlier society, to wonder about the supply chains and the practical knowledge required to undertake such a project. When we hold this idea of the schist fragment in mind, the Sphinx itself begins to feel different. It is no longer just a statue weathering in place, but a project, an active site of labor where choices were made about materials and methods, choices that left behind subtle traces for us to find millennia later. The story is indeed in the details, and even the smallest stone can carry a message across time, waiting for someone to listen. The stones at Giza hold more than geological secrets, they also point toward the sky. To understand the Sphinx's possible age, we must lift our gaze from its weathered flanks to the stars it has watched for millennia. This leads us to the field of archaeoastronomy, the study of how ancient cultures understood and encoded celestial patterns into their monuments. Here, a compelling and separate line of evidence emerges, one that aligns with the idea of a vastly older Sphinx. It centers on the monument's most defining feature, its form. The Sphinx is not a human king, it is a lion with a human head. Why a lion? The traditional explanation links it to the sun god and royal power, but some researchers propose a more literal, astronomical answer. They suggest the Sphinx was built to represent the constellation Leo, the lion, and to mark a very specific moment in the great celestial cycle. The theory, notably advanced by researchers like Robert Bovell, hinges on a phenomenon known as the precession of the equinoxes. This is the slow, wobbling rotation of Earth's axis over a cycle of approximately 26,000 years. Because of this wobble, the backdrop of stars that rises at the spring equinox, the first day of spring, changes over centuries. Today, the constellation Pisces rises at that moment. 2,000 years ago, it was Aries. If we rewind the celestial clock far enough, we find a striking alignment. Around 10,500 years before the Common Era, the constellation Leo would have risen due east at the dawn of the spring equinox. Now, picture the Giza plateau at that distant dawn. The Sphinx, a colossal lion carved from the bedrock, gazes precisely eastward. At that specific moment in history, it would have been staring directly at its own celestial counterpart, Leo, as it ascended on the horizon. This is not a vague association. It is a precise, geometric relationship between a terrestrial statue and a cosmic event. Could this be coincidence, perhaps? But within the context of a culture advanced enough to carve such a monument, it presents a powerful motive. If the Sphinx's builders were keen astronomical observers, they might have sought to anchor a significant celestial event in the very landscape. Creating a lion on the ground to mirror the lion in the sky at a pivotal seasonal turning point transforms the monument from a mere statue into a permanent clock, a calendar written in stone and stars. This archaeoastronomical argument provides a cultural and symbolic reason for the Sphinx's existence that fits neatly with a timeline far older than dynastic Egypt. It suggests a society deeply attuned to the heavens, one that measured time not in years of kings, but in the grand, slow sweep of the constellations. This stellar theory operates independently from the geological water erosion evidence, yet they whisper the same number. Both lines of inquiry, one looking down at the stone and the other looking up at the sky, converge on a similar epoch, a period around 9,000 to 12,000 years ago. One explains how the Sphinx was weathered, the other suggests why it might have been built in the first place. Together, they form a more complete, though still controversial, picture. They propose that the Sphinx is not an outlier in history, but a deliberate marker placed at a unique astronomical crossroads, a silent sentinel forever commemorating a moment when the earthly and the celestial perfectly align. Its gaze, then, is not blank. It is fixed on a date, a specific dawn lost in deep time, waiting for us to decipher its silent, stone-bound message. Beneath the pores of the great guardian lies a flaw that tells its own pragmatic story. The Sphinx enclosure is not just a hole in the ground. It is a constructed space with an engineered floor. When cleared of sand, researchers have noted features carved directly into the bedrock at the base of the pit. These are not random erosional patterns, but what appear to be deliberate channels and shallow basins. Some geologists interpret these as ancient drainage systems, practical architecture designed for one clear purpose: to manage flowing water. Think of a modern driveway or patio, subtly sloped with small trenches to direct rainwater away from a foundation. The principle here is the same, but executed on a monumental scale. The builders, it seems, anticipated that water would collect in this deep pit, and they took steps to control it, to channel it away from the statue's base and prevent pooling or undermining. This is a critical piece of evidence because it moves the discussion from what happened to the stone to what the builders intended for it. If the primary environmental challenge for the Sphinx's creators was wind-blown sand, these drainage features make little sense. Sand does not flow in channels, it drifts and accumulates. You would not carve gutters to manage a dust storm. The presence of these features, however, aligns perfectly with a climate that experienced heavy, periodic rainfall. It indicates that the people who shaped this enclosure lived with water as a constant, practical concern. They weren't just enduring the weather, they were proactively engineering solutions for it, integrating water management right into the bedrock of their most sacred site. This transforms the Sphinx from a passive victim of erosion into an active participant in a wetter world. The drainage channels are the fingerprints of a practical mind, a builder who looked at the sky, anticipated the deluge, and carved the very ground to handle the runoff. This architectural choice strongly supports the climatic argument. It suggests the monument was designed for the environment in which it was built, an environment where managing rainwater was a necessary and routine part of construction. The floor of the pit, therefore, is more than a foundation. It is a built response to a forgotten reality, a silent testament to a world where the greatest threat to a stone lion was not the dry, scouring wind, but the life-giving yet relentless power of the rain. But the stone's story does not exist in a vacuum. It is heard by people, by nations, and by a world with deep emotional and economic investments in a particular past. This is where the mystery of the Sphinx leaves the realm of pure geology and enters the complex landscape of human identity. The Great Sphinx is not merely an archaeological site. For modern Egypt, it is a profound symbol of national pride, a timeless emblem of a civilization's genius that has endured for millennia. It anchors a cultural heritage that is taught in schools, celebrated in art, and forms the bedrock of a vital tourism industry. Millions of visitors each year come to stand in awe before a monument they believe was built by the pharaohs of the 4th dynasty. This narrative is powerful, stable, and economically essential. To suggest that the Sphinx may belong to a different, unknown culture predating the pharaohs by thousands of years is not just an academic adjustment. It is perceived by some as a challenge to that cultural ownership, a potential dilution of a proud and specific heritage. The question becomes, who does history belong to? When science proposes a new origin story for a national icon, it can feel less like discovery and more like dispossession. This creates a powerful, often unspoken, resistance that operates alongside the scientific debate. The economic dimension is equally real. The story sold to tourists, woven into guidebooks and museum displays, is a coherent package. It connects the Sphinx to the pyramids, to the pharaohs, to a golden age we think we understand. A radical redating introduces uncertainty, complexity, and a narrative that is, for now, incomplete. It asks the public to embrace a mystery where there was once a clear answer. For institutions built around a specific historical timeline, embracing such a shift is not simply a matter of updating a textbook. It could mean rethinking exhibitions, retraining guides, and reshaping a global brand that has taken centuries to build. The potential disruption is immense. This interplay reveals that solving the Sphinx's age is not just a technical puzzle. It is a deeply human one, involving the guardians of culture, the stewards of economy, and the protectors of a story that gives meaning to a nation. The resistance, therefore, is not necessarily a rejection of science, but a protective instinct. It is the weight of legacy pushing back against a new, destabilizing idea. To move forward, any new evidence must be so overwhelming that it can support not only the geological argument, but also the cultural transition that would follow. The Sphinx thus sits at the center of a silent tension between the story written in its stone and the story written in the hearts of those who cherish it. Unlocking its secret requires patience with both. To read the deepest history of a stone, we must look at its smallest pages. Beyond the visible scars and channels lies a hidden world of evidence, recorded in the crystal structure of the limestone itself. This is the realm of petrographic analysis, a form of high-tech forensic geology. Imagine taking a sliver of rock from the Sphinx enclosure, a slice so thin that light can pass straight through it. Scientists mount this translucent slice on a glass slide and place it under a special microscope that uses polarized light. Under this lens, the stone transforms. It is no longer a solid gray block. It becomes a vibrant mosaic of interlocking mineral crystals, each one telling a part of the environmental story it has endured. This is like reading a stone's microscopic diary, with entries written in the language of crystal shapes, fractures, and chemical alterations. Petrographers can see, in exquisite detail, the sequence of events that have acted upon the rock. They can distinguish between the rounded edges of grains that have been chemically dissolved by water and the sharp, shattered edges caused by physical impacts from wind-blown sand. Some analyses of Sphinx limestone samples suggest a particularly telling sequence. The deepest, most pervasive alteration visible at the microscopic level appears to be chemical dissolution. This is where water, especially slightly acidic rainwater, has seeped into the stone and slowly eaten away at the bonds between mineral grains, leaving behind a softened, pitted texture. This kind of damage takes a very long time and a lot of water to achieve. Layered on top of that fundamental chemical weathering, the petrographic evidence can then show signs of a different process, the physical abrasion from wind-driven sand. This appears as a later overprint, scouring and fracturing the already weakened surface. This granular timeline is incredibly powerful. It doesn't just say the stone was weathered. It suggests the order of the weathering forces. First came a prolonged period of water interaction, a chapter that fundamentally changed the rock's internal structure. Then, much later, came the desert winds, etching their own signature over the older, water-damaged canvas. This microscopic testimony supports the idea of two distinct climatic chapters in the Sphinx's life. It provides a tool that can, in theory, separate the ancient rain events from the more recent sandstorms, offering a forensic breakdown of the monument's environmental history. Think of it like analyzing the layers of paint on an old wall. The deepest layer might be a primer applied in a damp climate, which has caused some mildew and bubbling. On top of that, you find layers of newer paint applied in a dry era, which are now cracking from sun exposure. Each layer holds clues about the conditions when it was applied. Petrographic analysis does this for stone. It allows geologists to move beyond interpreting large-scale shapes and to examine the very fabric of the rock, building a timeline of stress and exposure from the inside out. This evidence adds a profound new dimension to the investigation. It is no longer a debate about what we see with our eyes on the monument's surface. It becomes a conversation about what we can prove with light and magnification in its crystalline heart. The stone's diary, written in a language of light and mineral, may hold the most precise record of all, waiting patiently for us to translate its ancient, weathered text. The story of water on stone now expands beyond the sands of Egypt to touch the entire planet. To understand the Sphinx's deepest scars, we may need to look at a chapter of Earth's history marked by sudden, violent change. This brings us to a period known as the Younger Dryas, a climatic event that unfolded roughly 12,800 to 11,600 years ago. This was not a gradual shift. Scientific data from ice cores and geological records across the globe tells us it was an abrupt return to glacial conditions in the midst of a warming world. Temperatures in the northern hemisphere plummeted over just decades, a dramatic reversal that lasted for over 1,000 years. The causes are still debated, with theories ranging from shifts in ocean currents to the possibility of a cosmic impact event. But the consequences were global and profound. For regions like North Africa, the Younger Dryas likely meant a radical transformation in weather patterns. As the world cooled, the jet streams and monsoon systems that bring rain would have been thrown into chaos. One prevailing scientific model suggests this period could have brought intense, episodic deluges to areas that are now desert. A final, furious chapter of the wet epoch before the arid age truly set in. This is where the geological threads connect. The profound water erosion seen on the Sphinx, which requires centuries of heavy rainfall, finds a potential culprit in this documented, planet-wide upheaval. If the monument's initial carving predates this event, it would have stood exposed during a time of catastrophic and relentless storms. The vertical channels and deep recesses could be the direct result of Younger Dryas rainfall, a 1,000-year onslaught that battered the limestone guardian. This theory does something remarkable. It lifts the Sphinx mystery from a local Egyptian puzzle and places it firmly within a global context of climatic catastrophe. The statue is no longer an isolated anomaly, but a potential witness stone, a silent recorder of one of Earth's most dramatic recent transitions. It invites us to see it not just as a cultural artifact, but as a geological survivor. Imagine it standing on the Giza plateau, not as the barren rock we see today, but as part of a greener, wetter landscape. Then the climate shifts violently. The skies open, and for generations torrential rains pound its form, etching the story of that global chill into its very body. This perspective reframes the question of its age. Instead of asking if it is older than Egypt, we begin to ask if it is a monument from the before time, from the closing act of the last ice age. The Sphinx, in this light, becomes a marker at the boundary between two worlds. The lost world of the late Pleistocene and the emerging world of the Holocene, the epoch in which human civilization as we know it was born. Its weathered face gazes not just east but backward across a threshold of global change, holding within its stone the memory of a planet in tumult. The weathering on the Sphinx holds a clue in its very shadows. Look closely at the enclosure's vertical walls, especially in the corners and recesses that are partially shielded from the prevailing north winds. These are not the exposed, windward faces that would bear the brunt of a sandstorm. They are the sheltered spaces, the nooks that should, in theory, be preserved. Yet here, the erosion is just as deep, just as dramatically etched into the stone. The vertical channels and scalloped hollows carve through these protected areas with the same intensity as they do on the more exposed surfaces. This simple observation creates a significant problem for the theory that wind-driven sand is the primary sculptor. Think of a sandblaster. If you were to sandblast a complex object, the areas directly facing the nozzle would be deeply scoured, while the sides and back, the sheltered leeward surfaces, would remain relatively untouched. The abrasive stream is directional and forceful, but it cannot easily bend around corners to erode what it cannot directly hit. That is the logic of Aeolian abrasion. Yet at Giza, the weathering pattern defies this logic. It is omnipresent. It envelops the stone. This suggests the weathering agent was not a directional force like wind, but an enveloping, pervasive one. It points toward an environment saturated with moisture, where humidity could linger in still air and precipitation could fall from all directions, seeping into every pore and fissure of the rock, regardless of its orientation. Water does not need a direct line of sight. It flows, it condenses, it penetrates. In a climate with significant rainfall and high humidity, every surface exposed, sheltered, vertical or horizontal, is subject to chemical dissolution and erosion over a long enough period. The profound weathering in these protected niches is a quiet but powerful argument. It indicates that the entire monument, every inch of its carved enclosure, was subjected to a uniform climatic regime for a very long time. This was not a sporadic event, but a sustained condition that allowed the slow, patient work of water to reach everywhere. It transforms our understanding of the weathering from a surface phenomenon to an environmental immersion. The stone was not just scoured, it was soaked through, from its most prominent brow to its most hidden crevice, telling a story of a world that left no part of this guardian untouched. Laser light now dances across the ancient stone, mapping every contour with a precision the human hand could never achieve. This is the cutting edge of the Sphinx investigation, where modern technology builds a bridge to deep time. Tools like LiDAR, which stands for light detection and ranging, and advanced photogrammetry are revolutionizing the debate. Imagine a low-flying aircraft or a ground-based scanner sweeping the monument with millions of laser pulses every second. Each pulse bounces off the stone and returns, measuring the exact distance to create a point cloud, a digital constellation of data. From this cloud, software constructs a three-dimensional model of the Sphinx so accurate it captures the depth of a single erosion channel. This is more than a photograph, it is a perfect digital twin, a virtual monument that researchers can study from anywhere in the world, rotating it, zooming into its fissures, and analyzing its geometry without ever touching the stone. The implications are profound. For the first time, scientists can perform non-invasive, forensic-level analysis. They can quantify the volume of rock lost from specific layers, measure the precise angles of weathering, and create detailed cross-sections of the enclosure walls. This data moves the discussion from qualitative observation, what the weathering looks like, to quantitative measurement, exactly how much erosion has occurred and in what specific patterns. But the true power of this digital twin lies in its ability to run experiments through time. Using sophisticated simulation software, researchers can subject the model to virtual climates. They can program it with thousands of years of simulated wind patterns at specific speeds and sand densities. They can then run a separate simulation, bathing the digital Sphinx in centuries of virtual rainfall of varying intensity. By comparing the resulting virtual erosion patterns to the actual laser-scanned model, they create a powerful testing ground. Does a millennium of simulated sand abrasion produce the deep, vertical channels we see? Or does the model only match reality when subjected to long-term water flow? This technological approach offers a potential path beyond the stalemate of interpretation. It allows for the variables to be isolated and tested in a controlled, repeatable environment. The early pioneers of the water erosion theory, like Robert Schoch, worked with photographs, first-hand observation, and geological principles. Today's researchers have at their disposal tools those pioneers could scarcely imagine, instruments that can see the monument in ways light itself cannot. This digital frontier is quietly transforming an ancient mystery into a series of solvable equations. It promises a future where the question of the Sphinx age may not be answered by a new inscription or artifact, but by the silent, relentless logic of data and simulation. The surface of the Sphinx holds a chemical story written in a language we are only beginning to translate. Over centuries, stone exposed to the elements doesn't just physically wear down. It undergoes a subtle chemical transformation, creating a distinct weathered layer that geologists call a weathering rind. This rind is not just a crust of dirt. It is a dynamic environmental archive, a thin skin on the stone that has absorbed and recorded the chemistry of the atmosphere and rainfall that has bathed it for millennia. Think of it like the patina on an old bronze statue, but formed not by human hands, but by the slow conversation between rock and climate. Every drop of rain that has ever fallen on the Sphinx carried with it a tiny chemical signature, dissolved gases from the atmosphere, trace minerals from distant dust storms, even the faint isotopic fingerprints of ancient weather patterns. Over thousands of years, these minute interactions have altered the very surface chemistry of the limestone, embedding a record within that weathering rind. The potential here is extraordinary. By taking microscopic samples from this rind and analyzing them with modern mass spectrometers, scientists could, in theory, read that record. They could look for specific isotopic ratios, like those of oxygen, which can tell us about the temperature and source of the rainwater that fell. They could analyze trace elements that might indicate whether the atmosphere was dustier or cleaner in the past. Most intriguingly, they could assess the acidity or pH of the ancient rainfall. Water that has filtered through a lush, vegetated soil, like that of a green Sahara, becomes slightly acidic from organic compounds. This acidic water is a far more aggressive agent of chemical dissolution than the neutral water of rare desert downpours. If the weathering rind on the Sphinx shows geochemical evidence of prolonged exposure to this kind of biologically active, acidic rainfall, it would be powerful, direct evidence for a sustained wet and vegetated period in its deep past. This line of inquiry remains in its early stages for the Sphinx, a future frontier of research, but it represents a move from interpreting shapes to analyzing molecules, from reading the macro story of erosion to decoding the micro story of chemistry. It promises a form of proof that is less about interpretation and more about direct measurement. The stone's surface, therefore, is not just scarred. It is inscribed with a complex chemical text, a testament written atom by atom, waiting for the right tools to reveal what the ancient skies and soils were truly like when this guardian was young. This silent guardian on the Giza plateau is not an anomaly. It is part of a chorus, a growing collection of ancient voices speaking from stones around the world, each one whispering that our historical timeline may be missing entire verses. The Sphinx, with its geological and astronomical puzzles, finds echoes in distant lands. In southeastern Turkey, the site of Göbekli Tepe rises from a barren hill. Discovered only decades ago, this complex of massive, T-shaped limestone pillars arranged in circles was deliberately buried around 10,000 years ago. Its construction, however, dates back over 11,500 years, to a time when humanity was supposedly composed only of small, nomadic hunter-gatherer bands. Yet here they were, carving and erecting multi-ton stones with intricate animal reliefs, demonstrating sophisticated social organization and symbolic thought millennia before the invention of writing or settled agriculture. Similarly, on the island of Java in Indonesia, the terraced megalithic site of Gunung Padang presents another profound challenge. Initial surveys and core samples suggest the hill is not a natural formation, but a layered, man-made pyramid-like structure, with the deepest layers potentially dating back over 20,000 years. While these dates are fiercely debated, The very existence of such monumental architecture in these timeframes forces a fundamental re-evaluation. What if the Sphinx is not a lonely outlier, but a key piece in a global pattern? These sites scattered across continents share a common thread. They are monumental, enigmatic, and stubbornly older than the conventional narratives of civilization's dawn allow. They suggest that the period following the last ice age, the early Holocene, was not a blank page of simple survival. It may have been a dynamic era of experimentation, cultural flowering, and monumental ambition by societies we have barely begun to understand. These were not the empires we read about in history books. They were likely different kinds of cultures, perhaps organized around spiritual centers, astronomical knowledge, or communal gathering, leaving behind not cities or written records, but enduring stone sanctuaries. Viewing the Sphinx through this wider lens changes everything. The debate over its age is no longer just an Egyptian controversy. It becomes a single chapter in a much larger, unfolding story about human prehistory. The geological evidence at Giza, the astronomical alignments, the sheer scale of the work, all fit into a pattern emerging from the ground in Turkey, Indonesia, and elsewhere. This perspective invites a humbling possibility. Perhaps the story of human achievement is not a single, linear climb from primitive to advanced, with civilization beginning in Mesopotamia and Egypt. Perhaps it is a story of multiple dawns, of cultures that rose to profound heights at different times and places, developed complex knowledge, expressed it in stone, and then, for reasons we can only guess, faded from memory, their greatest works left as cryptic landmarks for future generations. The Sphinx, then, is more than a statue. It is a geographical anchor point in this lost world map. Its silent, weathered gaze connects it to Göbekli Tepe's carved beasts and Gunung Padang's terraced slopes. Together, they form a scattered, global network of clues, a puzzle of forgotten origins waiting to be assembled. Our challenge is to listen to what all these stones are saying, and to have the courage to rewrite the first chapters of our own story. This pursuit of knowledge brings us to a quiet, difficult crossroads. Every potential path forward carries a significant cost. To move beyond theories and models, to find the kind of evidence that could settle the debate once and for all, would likely require more direct investigation. We could drill core samples deep into the enclosure floor to analyze the subsurface weathering layers in minute detail. We could conduct targeted excavations in specific areas, searching for tool fragments, organic material, or construction layers that could be carbon dated. The scientific temptation is powerful, almost overwhelming. A single, datable artifact from beneath the Sphinx's pores could rewrite textbooks. Yet here, science meets a profound ethical responsibility. The Great Sphinx is not a laboratory specimen. It is a fragile, ancient monument, a symbol recognized across the globe as a World Heritage Site. Every insertion of a drill, every trench dug into its enclosure, is an irreversible act. It is a physical intervention on a scale that cannot be undone, a permanent alteration to a structure that has survived for millennia. The tension is clear and deeply human. On one side, we have an insatiable thirst to understand our origins, to solve one of history's greatest puzzles. On the other, we have a duty of stewardship, a promise to protect this irreplaceable treasure for the generations who will come after us, so they too can stand before its mystery and wonder. This is not merely a technical question of archaeology. It is a question of values. What matters more, the answer we seek today, or the preservation of the question itself for tomorrow? Some researchers argue that with modern, minimally invasive techniques, the risks can be managed, and the potential reward of definitive knowledge justifies careful action. They see the Sphinx as a library whose most important pages are still buried, waiting to be read. Others, including many conservators and cultural guardians, urge extreme caution. They point out that the monument has already endured significant erosion and restoration. They ask whether our current technology is truly refined enough to guarantee no unintended damage, and whether we, in this moment, have the right to potentially compromise its integrity for our own curiosity. This ethical layer adds a solemn depth to the entire mystery. It transforms the Sphinx from a passive object of study into an active participant in a moral dialogue. Its silence becomes a form of communication, reminding us that some truths are not ours to take, but may be offered only when the time is right. Perhaps the greatest lesson the Guardian imparts is about humility. Our pursuit of its age must be balanced with a deep reverence for the artifact itself. In our rush to label it, to pin it to a date on our timeline, we must not forget to listen. The stone has held its secret for thousands of years. It may choose to hold it a little longer, teaching us that some mysteries are not problems to be solved, but companions to be respected on the long journey of understanding our place in time. History is not just a collection of facts. It is a story we tell ourselves, a narrative woven from fragments to create meaning and continuity. The standard timeline of the Sphinx is a masterpiece of this kind of storytelling. It is elegant, coherent, and deeply satisfying. A powerful pharaoh in an age of pyramid builders carves his likeness into the living rock as an eternal guardian. This story connects the monument to the pyramids, to a golden age we feel we understand, to a lineage of kings whose names we know. It gives us a tidy chapter in the great book of human civilization. We cling to this narrative not out of stubbornness, but out of a profound psychological need. Humans are pattern-seeking creatures. We crave order, causality, and a sense that the past flows logically into our present. A clear story provides that anchor. It tells us who we are by showing us where we came from. The established Sphinx narrative does this beautifully, placing the monument firmly within the cradle of a civilization we celebrate. Then the geology speaks. The water erosion, the stratified weathering, the silent testimony of the stone itself introduces a dissonant note. It is a plot twist written not in the ink of papyrus, but in the very bedrock. This evidence threatens to rip a hole in that beautiful, coherent story. It suggests the Guardian was already ancient when the first pyramid architect drew a plan. Suddenly, the narrative is not just incomplete, it is potentially wrong. This forces us into an uncomfortable space. We must begin constructing a new story, one that is currently full of gaps and questions. Who were these earlier builders? Why did they carve a lion? What happened to their world? This new narrative is messy. It lacks the clean edges and named characters of the Egyptian timeline. It exists in the shadows of prehistory, a tale told only by weathering patterns and celestial alignments. Our minds resist this. We prefer the completed puzzle, even if some pieces are forced to fit, over the unsettling blank spaces of a new one. Accepting the geological evidence requires a fundamental shift. It means embracing mystery over certainty, complexity over simplicity. It challenges our need for a tidy historical continuum where civilization progresses in a straight, knowable line. The stone asks us to consider a different possibility, that history might be a series of cycles with brilliant dawns and long, forgotten nights. The true power of this mystery lies in that tension between the story we have always loved and the story the stone seems to tell. It is a reminder that our understanding of the past is always a conversation, a negotiation between the evidence we find and the meaning we desperately need to build from it. Standing before the Sphinx, many visitors describe a feeling that goes beyond sightseeing. It is a quiet, heavy sensation of time, a palpable aura of immense antiquity that seems to radiate from the weathered stone. This is not a detail from a guidebook, but a shared human experience reported by countless people from every corner of the globe. They speak of a humbling presence, a silent weight of years that makes 4,500 years feel almost recent. Could this intuitive, almost physical recognition of deep age be an unconscious response to the truth written in the rock? While entirely subjective and far from scientific proof, this collective perception is a powerful piece of the puzzle in its own right. It suggests that on some fundamental level we are sensing the monument's reality. Our eyes see the severe erosion, the deep fissures, the way the stone seems to melt into the earth. Our minds may not compute the geology, but our intuition whispers that this is not a monument from a familiar historical chapter. It feels like a relic from a world before our stories began. This emotional response underscores the Sphinx's unique power. It operates on two levels simultaneously. For scholars, it is a complex riddle of stratigraphy and weathering rates. For the human heart, it is an immediate, awe-inspiring encounter with deep time itself. The mystery, therefore, has a gravity that pulls beyond academia. It draws millions to stand in its shadow, not to solve an equation, but to witness a question carved in limestone. This universal draw speaks to something primal in our curiosity. We are drawn to edges, to boundaries, to the places where our known world meets the vast unknown. The Sphinx is precisely that, a sentinel on the border between recorded history and a forgotten epoch. Its silence is not an emptiness, but an invitation. It invites us to look past the dates in our textbooks and feel the scale of time in our bones, to stand before a mystery that reminds us our story is likely longer, stranger, and more wonderful than we have yet dared to believe. The stone has spoken, but its final word is not yet clear. So where do we go from here? The path to a definitive answer lies in a future of precise, interdisciplinary science. One of the most promising, yet delicate, avenues is targeted subsurface investigation. Imagine a carefully planned core drilling operation at a key location within the Sphinx enclosure, perhaps near the base of the western wall where the weathering is most severe. The goal would not be to dig a trench, but to extract a slender column of rock, a vertical timeline from the surface down to the unweathered bedrock. This core would be a geological manuscript. By analyzing the weathering Rinds' thickness and chemistry at different depths, scientists could construct a precise timeline of exposure. They could use techniques like cosmogenic nuclide dating, which measures the buildup of rare isotopes created when cosmic rays strike rock at the surface. This method can determine how long a stone face has been exposed to the open sky. If applied to the deepest, most weathered layers of the core, it could provide a minimum age for the carving of the enclosure itself, a number etched not in pottery but in atomic decay. Another crucial collaboration must blossom between climatologists and archaeologists. We need high-resolution climate models for North Africa spanning the last 15,000 years. These models must move beyond general trends to simulate localized rainfall patterns on the Giza plateau. Could they pinpoint periods of intense, sustained precipitation capable of creating the specific erosion patterns we see? By marrying this climatic data with geological analysis of the stone's dissolution rates, researchers could create a powerful, testable hypothesis for when the Sphinx endured its most formative weathering. The open questions are a map for the next generation. First, can we definitively separate the chemical signature of ancient rainwater from that of groundwater or capillary moisture? Second, if the Sphinx is older, where is the associated settlement debris, the tools, the everyday evidence of its builders? Their absence is a profound puzzle. Third, and perhaps most intriguing, if the core body was recarved, can advanced scanning technology detect subtle differences in tool marks or artistic style beneath the surface, revealing the hand of an earlier sculptor? This investigation is vibrantly alive. It awaits not just new instruments but new perspectives, minds willing to bridge the gap between the story of cultures and the story of the Earth. The final chapter on the Sphinx's age remains an open page, inviting us not to force a conclusion, but to follow the evidence with patience, respect, and an unwavering commitment to the truth, no matter how deep in time it may lie. The stone has presented its case not as a single fact, but as a chorus of converging whispers. When we listen to them together, a powerful harmony emerges. The profound vertical weathering on the enclosure walls, the deep subsurface alteration mapped by seismic tools, the stark contrast with the smoother, younger valley temple, the stratified erosion that follows the soft limestone layers like a roadmap, and the engineered drainage features anticipating rainfall, these are not isolated curiosities. They are threads in the same tapestry, each one reinforcing the narrative of a prolonged, wet climatic chapter in the monument's distant past. Individually, each piece of evidence invites a question. Collectively, they form a cumulative argument that is difficult to dismiss. The counter-arguments from wind and salt processes are serious and scientifically grounded, offering a plausible alternative framework. Yet, when weighed against the totality of the geological anomalies, they struggle to account for the omnipresent, deep, and stratigraphically conformable patterns we see. The preponderance of the evidence points toward an environment that has not existed at Giza for thousands upon thousands of years. This synthesis does not demand we name a new builder or pinpoint an exact year. Its power is more fundamental. It demonstrates with growing clarity that the standard 4,500-year timeline is geologically problematic. The stone itself appears to be out of sync with the story we have attached to it. When the physical fabric of a monument consistently suggests a history that contradicts the established historical context, it is not a call to ignore the history. It is a compelling mandate for a major rethink. We are not being asked to choose between archaeology and geology, but to forge a new partnership between them, one where the Earth's own testimony is given its full and rightful voice in the court of human origins. The Sphinx does not offer its secrets easily. It simply waits, a silhouette against the desert sky, its stone face holding a silence that has outlasted dynasties and empires. This weathered visage has become something far greater than an archaeological site. It is the ultimate symbol of historical mystery itself, a silent sentinel standing guard over the deepest questions of time and human origin. Our journey through the evidence, the geology, the astronomy, the silent testimony of its stone does not end with a neat answer. Instead, it circles back to where it began, to the profound humility we feel in the shadow of such a monument. Whether its true age is 4,500 years or 10,500, the Sphinx's most enduring power lies not in a date, but in its relentless ability to make us question. It pulls us out of the comfort of our textbooks and into the vast, uncharted territory of the past. In a modern age saturated with instant information and easy answers, the Sphinx remains a monumental question mark carved in limestone. It refuses to be solved with a quick search or a simple fact. It demands patience, interdisciplinary respect, and a willingness to sit with uncertainty. This great guardian teaches us that some truths are not destinations, but journeys of persistent inquiry. It reminds us that history is not a closed book, but an ongoing conversation between what we have discovered and what we have yet to understand. To stand before it is to feel the weight of deep time, and to recognize that our story is likely longer, stranger, and more wonderful than any single narrative can contain. The Sphinx, in its eternal silence, offers the greatest lesson of all. True wisdom begins with the courage to admit what we do not know and the wonder to keep searching. The layers of limestone hold more than just the memory of ancient rain. They hold an invitation to see our own history with new eyes. We have walked through the evidence, from the deep vertical fissures that whisper of forgotten storms to the silent testimony of seismic scans and the celestial clockwork of the stars. Each piece builds a portrait of a monument out of time, a guardian whose origins may reach back into a misty epoch long before the first dynastic stone was set. This is not about discarding the incredible achievements of ancient Egypt, but about expanding the canvas upon which human ambition is painted. The debate itself, the vigorous clash between geology and established history, is not a failure of knowledge. It is its greatest triumph. It proves that our past is not a static exhibit behind glass, but a living, breathing field of inquiry, constantly reshaped by new questions and new ways of seeing. The Sphinx, in its weathered majesty, has become the ultimate teacher in this regard. It does not give easy answers. Instead, it models a profound intellectual humility, reminding us that the most certain stories are often the ones most in need of a second look. So where does this leave us? Here at the edge of the desert and the frontier of the past, the evidence on the table is compelling, a geological puzzle that challenges a cornerstone of historical narrative. Yet the final chapter remains unwritten, awaiting future tools, future minds, and perhaps a future discovery that can bridge the gap between the story in the stone and the story in the scrolls. This open-endedness is not a weakness in the investigation. It is the very source of its power. It invites you into the conversation. Having journeyed through the data and the disputes, where does your intuition land? Does the cumulative weight of water erosion and ancient alignments reshape your sense of time? Or does the elegant coherence of the traditional timeline still hold your trust? The comment section below is your platform. Share your perspective, your questions, or the piece of evidence that resonates most deeply with you. These discussions are how understanding grows. If unraveling history's great enigmas captivates you, consider subscribing. Our channel is dedicated to these deep dives, to exploring the cracks in the official story and listening to the whispers from the edges of time. The Sphinx's greatest lesson is etched not in its solution, but in its enduring mystery. It teaches us that sometimes the most profound truths are not delivered in declarations, but discovered in the patient, collective pursuit of a question. The oldest stories, after all, are often written not in words, but in stone, waiting for us to learn how to read them.